Good day all of you. Today in this video I am going to explain the classification of systems. Classification of systems. In the previous videos I completed the classification of signals. Now it is classification of systems. The systems are classified into continuous time and discrete time, continuous time and discrete time systems, linear and nonlinear systems, third one, time varying and time invariant systems, fourth one, causal and non-causal signals, stable and unstable systems, next static and dynamic systems, last one, lumped parameter and distributed parameter systems, lumped parameter and distributed parameter systems. Okay, so this is the classification of systems: continuous time and discrete time, linear and non-linear, time varying and time invariant, causal and non-causal, stable and unstable, static and dynamic, lumped parameter and distributed parameter systems. So the first classification is continuous time CT and discrete time DT system. CT system and DT system. Okay. So for continuous time, let us see about continuous time system. Take a continuous time system. CTS is continuous time system. For the continuous time system, the input is a continuous time signal and the output is also a continuous time signal. Input is continuous and output is also continuous. You know, x of t is the representation for continuous signal and y of t is the representation for continuous output signal. So if a system takes the continuous input and gives out the continuous output, the system is said to be continuous time system. Okay. Then take your discrete time system. The discrete time system take input as discrete sequence x of n and gives output as a discrete sequence. So this type of system is called discrete time system. Okay. So continuous time system, input is continuous signal, output is also continuous signal. For discrete time system, input is discrete signal, output is also discrete signal. Next classification is linear and nonlinear systems. linear and nonlinear systems. Let us see the linear first. Linear system. A system is said to be linear if it satisfies the properties of superposition and homogeneity. Superposition and homogeneity. A system satisfies the concept superposition and homogeneity, then the system is said to be linear system. Then let me explain what is superposition. Suppose if x1 of t is the input and if it produces the output y1 of t, and for input x2 of t, if the system produces output y2 of t, then for x of t equal to x1 of t plus x2 of t, if the system produces y of t which is equal to y1 of t plus y2 of t, then the system is satisfying superposition. Okay, so superposition property, if a system produces y1 of t for the input x1 of t and y2 of t for input x2 of t, then for the same system if you apply x of t which is x1 of t plus x2 of t, if the system also produces the output which is equal to the sum of outputs, then the system is satisfying superposition principle. Then I'll see what is homogeneity. Homogeneity. Suppose for a system the input x of t is given. If that system is producing an output y of t, if you scale this input signal like a into x of t and give that scaled version of input to the system, and if the system produces the same scaled version of output, the system is said to have homogeneity. Okay? So, if the system produces y of t for the input x of t, and if the input is scaled by a factor a, if the system output is also scaled by a factor a, then the system is said to have homogeneity. Okay, so totally what is superposition and homogeneity? x1 of t plus x2 of t must produce y1 of t plus y2 of t. This is your superposition. Superposition. And a into x of t has to produce the same a into y of t. This is called homogeneity. If you combine these two, how to combine? See here, a into x1 of t plus b into x2 of t, if it is the input to the system, and if the system produces a into y1 of t plus b into y2 of t, then the system is satisfying both superposition and homogeneity. Means the system is said to be linear system. See here, there exists sum of inputs and the output is sum of outputs, and the inputs are scaled by the factors a and b. Here the outputs are also scaled by the factor a and b. Okay, so this type of system is said to be a linear system. Then what is meant by nonlinear system? Simple. nonlinear system won't satisfy, it won't satisfy either superposition or homogeneity. It won't satisfy superposition or homogeneity. Okay. So this is nonlinear system. Now we'll see some problems on linear and nonlinear systems. Okay. So first, given y of t equal to t into x of t, you have to find whether the system is linear or not. Find whether the system is linear or not. Linear or not. What is the system? System is y of t equal to t into x of t. So now take the first input x1 of t. For this, your given system equation becomes y1 of t equal to t into x1 of t. For the signal x2 of t, your system equation becomes y2 of t equal to t into x2 of t. Carefully observe the procedure. Let x3 of t equal to a into x1 of t plus b into x2 of t. Then the system is said to be linear if you get y3 of t, which is a into y1 of t plus b into y2 of t. Let be equation number 1. Okay. Then now consider the equation y of t equal to t into x of t. Now write y3 of t, that is t into x3 of t. Now in the place of x3 of t, you substitute a into x1 of t plus b into x2 of t. What are you going to get? T into a into x1 of t plus t into b into x2 of t. A into t x1 of t plus b into t x2 of t. So what is t x1 of t? Your y1 of t. What is t x2 of t? Your y2 of t. So it is b into y2 of t. What is this? This is y3 of t. Let be equation number 2. Now see here. Equation number 1 and equation number 2 are same. So then the system is said to be linear. Okay, I'll repeat the procedure. This is your given system function. So first you have to assume one input signal x1 of t. For that you have to write the output y1 of t as t into x1 of t. And assume another input x2 of t. Write another output equation y2 of t equal to t into x2 of t. According to the superposition and homogeneity concepts, means the linearity concept, suppose if x3 of t is a into x1 of t plus b into x2 of t. These two inputs are scaled and summed. Then generally for a linear system, what is the output? Output is y3 of t equal to sum of scale versions of the outputs a into y1 of t plus b into y2 of t. Actually, these you have to get. Okay. But you have to check here. How to check? Now consider y of t equal to t into x of t, the given function. Write y3 of t like this, t into x3 of t. Now in the place of x3 of t, you have to substitute this equation, a into x1 of t plus b into x2 of t. Then solve this. You will get these two terms. If you observe these two terms, these are nothing but a into y1 of t plus b into y2 of t. So now if you observe 1 and 2, the system is said to be linear. System is said to be linear system. Now we'll consider another problem. Y of t equal to x square of t. We'll follow the same procedure. Okay. Now, for x1 of t, y1 of t equal to x1 square of t. For x2 of t, y2 of t equal to x2 square of t. Let x3 of t equal to a into x1 of t plus b into x2 of t. Then the system is said to be linear if y3 of t equal to a into y1 of t plus b into y2 of t. Okay. So let be equation number 1. Now again consider your given system expression. Consider y of t equal to x square of t. Now write y3 of t, which is nothing but x3 square of t. Now when x3 of t place, substitute your equation a into x1 of t plus b into x2 of t. A into x1 of t plus b into x2 of t. As you have square, just keep square. So what is this? A square x1 square of t, it is like a plus b whole square, plus b square x2 square of t plus 2ab x1 of t into x2 of t. See equation number 1 and 2. 1 and 2. 1 and 2 are not same. So the system is said to be, therefore the system is said to be non-linear. Okay. Then let us see another problem. Y of n equal to 2x of n minus 3. We'll follow the same procedure. For x1 of n, if x1 of n is input, y1 of n equal to 2 into x1 of n minus 3. And for x2 of n, y2 of n equal to 2 into x2 of n minus 3. Then take x3 of n, that is a into x1 of n plus b into x2 of n. The system is said to be linear if the output is y3 of n, that is a into y1 of n plus b into y2 of n. The output must be like this. Okay, now consider the system equation. Y of n, that is 2x of n minus 3. Then write y3 of n. Two into x3 of n minus 3. In the place of x3 of n, substitute this. Okay. So this is the y3 of an expression. Now observe 1 and 2. Both are same? No. So the system is said to be nonlinear. Let us see another type of problems on linear and nonlinear systems. Okay. Find whether the system is linear or not. The systems described by the following equations. This is another type of problem. Let us take the first equation as dy of t by dt plus 3 into y of t is equal to x of t. This is the first equation. This is the system differential equation. Now, see the procedure carefully. For x1 of t, consider the input initially as x1 of t. You write the system equation. Then what is the system equation? D into y1 of t by dt plus 3 into y1 of t is equal to x1 of t. What is the meaning of it? For this system described by this differential equation, consider the system input as x1 of t. And if x1 of t is the input, output is y1 of t. So write this expression totally in terms of x1 of t and y1 of t. Then consider another input x2 of t which gives y2 of t. Okay. Then write the system equation. D into y2 of t by dt plus 3 into y2 of t is equal to x2 of t. x2 of t. Okay. So now take this as equation number 1 and this as equation number 2. Then do 1 plus 2. If you add 1 and 2 equations, see here the first terms d by dt of y1 of t plus d by dt of y2 of t. So you can separate d by dt. Then go for y1 of t plus y2 of t. Plus. Next term 3 into y1 of t plus 3 into y2 of t. Take 3 common. y1 of t plus y2 of t is equal to x1 of t plus x2 of t. Let be equation number 3. Observe the system equation number 3. See here, in equation number 1, input is x1 of t and this is the expression of output. And here, if input is x2 of t, this is the expression of your system equation. Then for the input, x1 of t plus x2 of t. This is for superposition and homogeneity concept. Let us take the constants as 1, no problem, 1. A is 1, B is 1. So A into x1 of t plus B into x2 of t like that. Then See this system equation here. Sum of inputs are producing sum of outputs. So that is called superposition actually. Sum of inputs has to produce sum of outputs. So as the three equations are similar, okay, so the system is said to be linear. Linear system. I think you understand. It's like the equation when the input is the sum of inputs. So see here the input is sum of inputs and the outputs are sum of outputs. Okay, so therefore the system is said to be linear system. Then take another problem. D into y of t by dt plus 2 into y of t is equal to x square of t. Okay, then follow the same procedure. Consider for x1 of t. For x1 of t, the equation is d into y1 of t by dt plus 2 into y1 of t is equal to x1 square of t. Let be equation number 1. For x2 of t, output is y2 of t. Write the system equation in terms of x2 of t and y2 of t. dy2 of t by dt plus 2 into y2 of t is equal to x2 square of t. Let be equation number 2. Then add 1 and 2. I'll get d by dt of y1 of t plus y2 of t plus 2 of y1 of t plus y2 of t is equal to x1 square of t plus x2 square of t. Observe the equation carefully. Is it like sum of inputs? No. Sum of inputs means here this term must be, carefully observe, this term must be x1 of t plus x2 of t whole square. This term must be like this. Then the sum of inputs will produce sum of outputs. If this equation is like this, then only the system is said to be linear. Okay, but here the equation is not like that. Hence, the system is said to be nonlinear. Obviously, if the system equation consists of a square term, then damn sure the system is nonlinear system. Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.